Progress inspectors must verify that construction meets the provisions of the approved drawings. The inspections to be conducted must be detailed in the construction drawings, and contractors must allow time to conduct the inspections. The applicant of record may perform the progress inspections for the work they designed. Progress inspectors who are not the applicant of record must satisfy experience qualifications for the work they are inspecting. Supplemental inspectors can work under the direct supervision of a registered design professional and must meet certain experience qualifications for the work they are inspecting. However, they cannot sign the TR8 or EN2. So what are the TR8 and EN2? These are the required documents for construction sign-off. The TR8 is a form referred to as the Technical Report Statement of Responsibility for Energy Code Progress Inspections. The Progress Inspector must certify that all progress inspections noted on the original TR8 and on TR8s filed with any post-approval amendments have been satisfied. The Progress Inspector must sign and seal the TR8, certifying that inspected work complies with the approved drawings. The other required document for construction sign-off is the EN2 form, otherwise known as the Certificate of Conformance with As-Built Energy Analysis. Here, the Progress Inspector must certify on this form that the as-built values for energy in the building match the values in the latest approved energy analysis. If they do not, then an as-built energy analysis must be prepared by the applicant of record, and the Progress Inspector must certify on the EN2 form that the as-built values for energy in the building match the values in the as-built energy analysis. The as-built energy analysis must be professionally certified and submitted with the EN2 form at sign-off. Let's look at Rule 5001. The Energy Code Compliance Rule establishes the department standards for progress inspections during construction. Table 1 and Table 2 are progress inspections for energy code compliance for residential and commercial buildings. What you see here is the table headings. On the left, the inspection/test gives a general description of the inspection. But we would like you to look towards the right at the standard and code sections for more detailed information about what is to be included. Another rule, 101-07, is the approved agencies rule, and that describes the qualifications for progress inspectors for energy code compliance in subdivision C, paragraph 3. There is a requirement for progress inspections. Owners are required to retain registered design professionals to perform progress inspections. Such professionals must not have a conflict of interest for the project they are inspecting, and they must verify that the construction as it progresses conforms to the approved construction drawings. When related special inspections are required to be completed before progress inspections are performed, the progress inspector must not perform the progress inspections until they are completed. When construction that must be inspected differs from the approved drawings, such that the progress inspection cannot be adequately performed, the progress inspector must wait until the drawings and energy analysis are updated and approved as appropriate before commencing the inspections. Unless otherwise noted in Tables 1 or 2 in Rule 5001, the progress inspectors must inspect at least 15% of the construction work for a given progress inspection, and at least one of each unit type. Phased project inspections are permitted under certain circumstances, specifically when it refers to seasonally conducted inspections. I want to draw your attention to some of the links on our website that you may find helpful. What you see here is a progress inspections comparison chart between two codes. The one you see here is the difference between the project inspections required in the 2016 code versus the 2020 code. We also have one of comparison between the 2011 and 2014 code. And you may find those very helpful when you have projects that may have been approved under a previous code. So what if there is a conflict between Table 1 and 2 and the TR8 Statement of Responsibility? What if you, the inspector, believe that an inspection is missing? What you should do, since you work for the owner, is to notify the owner and the applicant of record of the inconsistency and request that it be corrected. But in the end, the EN2 references the approved energy analysis. So Table 1 and 2 on the approved EN page is the approved inspection list. What if non-compliant conditions are found that are not addressed by the approved construction documents? For example, you, the inspector, know that a space requires daylight controls, but the approved drawings do not show them. Can you certify that inspection? Again, notify the owner and the applicant of record of the non-compliant condition. Request amended drawings and that the non-compliant condition be corrected. Then recommend that you re-inspect. What you see here is the bottom portion of the TR8 form. And what it says is that you have completed the items specified herein and that you are certifying the following. Either that all work performed substantially conforms to approved construction documents, or that all work performed substantially conforms to approved construction documents except as indicated in the attached report. So here is the point where you can highlight that there are items that do not conform to the approved construction documents, or if you wish to, you can point out any omissions. This is where you would do that. On the EN2 form, however, it's a different story. The EN2 states that the as-built conditions do conform to the approved documents, and there are only 3 ways you can do that. The choice is that the as-built conditions conform to the originally approved energy analysis, or that they conform to the latest post-approval amendment, or that you are attaching a revised energy analysis. But what you are saying when you sign this form is that the EN2 states that as-built conditions conform to the approved documents. I'm going to turn control over to my colleague, Janet Meller, and she will take it from here.
Good afternoon. I hope everyone is well. I'm going to get set up here a little bit for a minute. Okay. I'm going to talk about best practices for performing TR8 inspections and submitting reports to the department. The department may request reports for a variety of reasons. They may be random audits, maybe to clear a violation or a notice of deficiency, to accept a discretionary item that was placed in the system by a plan examiner, or it may be as part of a pilot program. So, you've been audited. What happens now? What can you do to make the process go smoothly and efficiently? What documentation does an auditor need in order to verify that your report is accurate and complete? And what can DOB do to help? Take a look at the updated Rule 101-07. There's new information there about what's required, but it's general information. Please keep in mind that when working with an auditor, it's just not possible to include everything that a plan examiner or zoning examiner might need in order to approve plans. So therefore, it's not possible to include in a rule absolutely everything that an energy auditor might need in order to verify your reports. So the more information you provide, the better able your auditor is to understand and improve your reports. That's the bottom line here. There are also some good references on the Energy Code website. Please check there and check frequently because we'll be updating. So what will the sustainability enforcement auditors look for? The job of the TR8 auditor is to verify your reports for accuracy and completeness. In order for us to do that, you, the inspector, need to both show and tell. What that means is, don't just tell us it's compliant, show us that it's compliant. Show us how it's compliant. We'll ask for verification that the inspector did indeed visit the site. And Table 1 and Table 2 on the approved drawings will indicate for you and for us what inspections are applicable. All relevant conditions need to be verified. If deficiencies in the work are identified, you can recommend remedial action. Look to your owner for guidance on that. How much do they want you to do? If conditions are found that don't correspond to the approved drawings, either the energy analysis should be amended so as to verify that conditions are still compliant, or the conditions need to be amended to conform with the approved energy analysis. So which will it be? Or are they going to do nothing? That is what you will be putting on your report. What will help your auditor verify that your report is complete and valid? In order for your auditor to verify your report, here's the show part. What building are we looking at? Can we tell from your photos? Please show enough context so the building can be recognized. How can we verify that the photo was taken at the time of inspection? If it's date stamped, we can tell when in the construction process the photo was taken. Show us that the conditions are compliant. What are we looking at? What does it mean? And this photo here, is that a compliant condition? Would you submit that photo to show us that all is well with that installation? I suspect that your auditor might disagree. Is your report complete? The auditor will compare your reports to the approved drawings. Were you comparing conditions to the most recent approved drawings? Have there been PAAs? Have there been audits? Check the dates on the drawings against the AI ones in the system or verify it with the applicant. You want to make sure that you're looking at the correct set. Based on those approved drawings, did you look at everything that should be inspected? Were you comparing conditions to the most recent approved drawings? And are your photos date stamped? Is everything clearly documented by photos? Can we tell what we're looking at? Can we tell that the condition is indeed compliant? Do you explain how you determined that the conditions complied? Just saying okay or complies is not sufficient. Your auditor's not going to accept that. And did you find any deficiencies? Did you recommend remedial actions? Did they follow up on your recommendations to either amend conditions or amend drawings? Please document whether they did or did not. If they did, please explain what was changed. As mentioned before, if they don't amend the drawings or conditions, it's up to you and your professional judgment whether or not you certify that EN2 and whether or not you certify that inspection in BIS. So you're doing an insulation inspection, inspection 1A2 or 2A2. Auditors will want to know, are all R values and U factors accounted for? What was supposed to be there? What did you find? If the wall detail, for instance, shows that there's continuous insulation behind the stud cavity, how did you verify that it's actually there and it's not just cavity insulation alone? Did you poke holes in it? Hopefully not. Hopefully there's a better way. Does the contractor have photos of the installation? Can you tell from the installer's certificate that they installed both cavity insulation and continuous insulation in that wall? And is there a below-grade areaway? If so, is there slab edge insulation between the bottom of that areaway and the building? Balconies can be tricky. Did they actually put that thermal break product in there? Looks nice on the drawing. Is it really there? Don't forget the gas meter room or those vented mechanical rooms that are outside the thermal boundary. According to the mechanical code, the gas meter room vent cannot have a damper, so it's the equivalent of outdoors. It can get pretty cold. They can have the radiant heaters that are allowed by the energy code for outdoor use. They can heat trace piping, but because it's open to the outdoors, or even in a mechanical room that gets outside air, it's considered outside the thermal boundary, even if it has a damper. Check the ceiling, the walls, the door, and maybe the floor if the floor is over interior space. Check them for both insulation and for air sealing. And also, don't forget those overhangs, those recess entry ceilings. Those are areas that are often missed. Mechanical inspections. What are you checking? What equipment did they install? Does it match the drawings and schedules? Did they add interior cooling units that might put them over the limit of equipment that can be installed without an economizer? What mechanical system controls were required and what controls were provided? The commissioning process verifies that the equipment and controls work properly. The inspector verifies that they're there. They can't be commissioned unless they're actually installed. You may sometimes have to do a little research. For instance, the ERV Recovery Effectiveness Rating should be on the approved mechanical schedule, but you probably won't find it listed on the equipment label on site. You might have to look up the product model to get that information. And how did you verify that the maximum pipe length from the source of heated water to the fixture does not exceed the maximum length identified on the approved drawings? What was that length? The source of heated water can be the hot water heater, the building risers, the circulating water system, or a heat trace system. What did you do? What were you supposed to find? And what did you find? Lighting. If 100% of the lamps in a dwelling unit are high efficacy, there's no need to count them. But if there's a mixture of incandescent and high efficacy, you do need to give the percent. And you do need to count them if it's not a dwelling unit. And what lamps are found? Can you tell by looking the difference between a halogen lamp and an LED? They sometimes look alike. Halogen is generally not high efficacy. They're more efficient these days, but they're probably not high efficacy. If you're not sure, check the lumens per watt for that particular lamp. It's probably not going to be found on a label, and you may not want to climb up into the ceiling to pull down the lamp. You may have to do some research online, and you may have to get information from the contractor as to what was purchased. Do the fixture and lamp types match the energy analysis? What about lighting controls? Check the control schedule for what's required and the controls narrative for what the required functions are. They go together. Lighting control functionality needs to be verified by TR8 inspection? Do they have all the functions required by the Energy Code? How did you verify that? And if you believe that required controls are missing from the drawings, include that in your report along with remedial recommendations. What else will help the auditor verify that your report is complete and valid? If you come across conditions that cannot be verified in the field, it may require some digging. Mineral wool, for instance, probably doesn't have an R value label. Is there packaging lying around on site that shows what the R value per inch is? If not, how else can you find out? Are you going to take the contractor's word for it? Or you could ask for an invoice, then check the product literature against the invoice data. How many inches were installed? Did you measure it? The same problem may arise if they've scraped the stickers off the windows and doors already. You could ask for an invoice or some other proof of what was purchased, and then assume that what was purchased was actually installed. And then you can compare that information to the NFRC 100 test results for that fenestration. The Energy Code calls for insulation that is blown or sprayed to have an installer's certificate on site. Ask for it. It's supposed to be posted there. And also, please stamp your reports. Unfortunately, we do sometimes need to verify that the report actually did come from you. Blower door testing. Prevention of air leakage is a very important component in energy conservation. According to the U.S. Department of Energy, up to 40% of energy costs required to heat and cool buildings is due to air leakage. DOB is now auditing blower door tests, and we sometimes ask to attend the testing, especially on big buildings because they're more complicated to test. Table 1 and Table 2 show the testing standards. ASTM E779 is basically for houses, but it can be used for larger buildings if accommodations are made. But ASTM E3158 gives much better guidance for large building tests. Please read them. They're important, and we'll talk more about them in a little bit. The biggest problem area in testing seems to be in calculating the enclosure area. That's the total area of the walls, the floor, and the ceiling surrounding the test area. In the residential code, they might use the volume of the test area instead of the enclosure area. But the important thing to remember is that the boundary of the test area is not necessarily the same as the thermal boundary. It's a question of where they put the air barriers and where they sealed. The designer should be able to tell you this, and it will make the testing process go much more smoothly if you verify it in advance. It's not always easy to tell on site. In this diagram, for instance, they sealed the interior walls and ceiling of those spaces that are drawn in white on the diagram, not the exterior walls. If everything's buttoned up already, you probably won't be able to tell. And don't forget that gas meter room or the vented mechanical room. It's going to be outside the sealed boundary, so outside the enclosure area. If your air sealing report is being audited, we'll help you. Send the auditor your enclosure area or volume diagrams and the calculations, and he or she will help you verify them. We can't do this for everyone, but if your job is being audited, we will help you. Your job will then be to verify that the testing contractor enters the correct values into the manometer or the software. These photos show a manometer. In a large building, they will typically have a computer with software, and you'll be looking at a computer screen instead. Testing of large buildings is complicated. Wind and stack effect are significant factors, as is the size of the building and the need to maintain relatively consistent pressures throughout the whole test area for the duration of the test. ASTM E779, as was mentioned before, was originally written for houses. And when people began testing larger buildings, problems were encountered. The U.S. Army Corps of Engineers air leakage test protocol was developed to address those problems, and it describes some workarounds for the difficulties that commonly arise in large buildings. It's free. You can get it online. I highly recommend it. It has some nice fill-in-the-blank forms, too, that you can use. Then ASTM 3158 was written just for large buildings. It addresses those problems and incorporates some of the Army Corps recommendations. It has a table, Table 1, that lists setup procedures. Look at the middle column of that table. It says building envelope mechanical systems excluded. The mechanical systems are not part of the test. That table is where you'll find the preparations for testing a large building. They're not the same as the procedures described in the Residential Energy Code. In particular, E3158 allows the sealing of intake and exhaust vents, whereas the Residential Code only allows those vents to be closed, but not sealed. Troubleshooting their setup is important. On one test that we observed recently, the contractor had gone around and taped up all the perimeters of all ground floor windows and doors on both the interior and exterior. We told them that the test must reflect conditions found during occupancy, and surely they would not have all their entrances taped up. So we asked them to remove all the tape. They were worried that the building wouldn't pass, but happily it did. If it hadn't, though, the TR8 inspector would have had to call for a retest, and the contractor would have had to do more sealing. It's their responsibility to find the leaks. And coming soon, the air leakage and testing verification webinar. We've been working with a consultant to develop a webinar for TR8 inspectors that goes into more detail about air sealing tests. It's for inspectors. It's not for testing contractors. They have their own training, and if you're interested, you can go to the websites of blower door manufacturers to find their training manuals. But this webinar is just about what you, the inspector, should be on the lookout for when you observe and certify a large building test. It talks about setup procedures, problems you might encounter, what to verify, what's most important, and what to include in your report. These are recommendations, not requirements, but they're important recommendations. We hope to have this webinar posted on the Energy Code website soon, along with some excellent references that are already there. We also hope to have some more TR8 related references available, so keep checking back. We're working on guidelines that accompany the webinar. They'll essentially be Cliff Notes versions of ASTM E3158. That standard is a must read, but it's not an easy read, so we're hoping to make a user-friendly summary of it. It will also incorporate some recommendations that came from our consultants, but again, just suggestions, not requirements. The Air Barrier Continuity Plan. Some of you may have received audit notices about the ABC plan. We're currently conducting a pilot program to see what ABC plans are out there and if there is need for more guidance for both the design applicants and for TR8 inspectors. The ABC plan is not just a bunch of details. It's a plan to test or inspect each type of unique air barrier, joint, or seam in the building envelope for continuity and defects. That's the quote from the Energy Code. In the 2016 code, it was either inspection 2A6 or 2A7 or a combination of both. In the new Table 2, we now have an additional inspection, which is 2A8, which is just about the ABC plan. The ABC plan is something that needs to be done according to the details on the approved drawings and according to the notes and specifications provided to you by the design applicant. It's not just about, did they caulk the windows? It's also about seams in the air barrier and joints between dissimilar materials. What did they do, and does it comply with the ABC plan? So the ABC plan is a set of instructions to you, the inspector, from the applicant, from the designer. How many of the areas identified on the drawings are to be tested rather than inspected? How are they to be tested? In the lab? In the field? By whom are they to be tested? By you? By a consultant? What are you expected to look for when you do your visual inspection? How many instances of that condition should you be verifying? And what degree of imperfection is acceptable? Are you expected to test for adhesion? Are fish mouths on seams okay? How did you verify that they used the right sealants? Did they apply it correctly? How detailed a report do they want from you? Do they want you to recommend remedial actions or just report on it? Do they want you to verify if it was fixed? All this information should go into an ABC plan for you to follow. If you don't feel that you have been given enough information, ask the design applicant for more. And for your TR8 report, DOB will be looking for what was proposed versus what was found. How did you verify the quality of the installation? Where did you look? What were you supposed to find? And what did you find? And what if an envelope commissioning contractor has been hired? What is your role then? Well, it's pretty much the same as when you verify a blower door test. Did they do what they're supposed to do? Did they do what's described in the ABC plan? They'll probably do much more than that in an envelope commissioning job. But what aspects of that envelope commissioning process relate to the inspection of joints and seams in the air barrier for continuity and defects? You'll be reporting on their process and summarizing their results as they relate to the ABC plan. So, in conclusion, the more complete and clear the information that you send to the department, the more quickly and smoothly the review process will go. So we're going to take some questions from the chat room, and we also have here some email addresses where you can send questions that are about specific jobs or even general questions that we don't get to today or you think of later. So let me take a minute to look at the chat questions, okay? All right, I have the question, how can an inspector provide verification that he visited the site? We have been getting some nice elevation photos. And that has worked well. They shoot the photo with some surroundings, and then they zoom in on an address, or they provide a map that corresponds to, and then we can look on Google Maps and Google Earth and see, yep, that's the right building. And we will accept whatever you send. We'll discuss it with you if we think it's not good enough. Next question. Are as-built changes submitted with the EN2 report required to be picked up on a PAA, or can we submit changes with TR8 without the PAA? Now that's a good question. I think I'm going to try to rephrase this. The as-built conditions need to be documented, but the question I believe is, does it require a PAA? And I'm going to say I believe so, but we're going to get back to you because I'm not positive about that.
Your question will be answered in the chat.
Okay, I'll read that one. Is air leakage and air barrier testing required for existing commercial spaces in existing buildings where the storefront is not being affected or changed? The air leakage and ABC plan are only for new buildings. This is not a code requirement for renovations. Do you have any more?
We'll continue to take questions in the chat, and we'll continue to answer them as they come in. Thank you for your attendance.